Now I've got the zones, I've got the constitutive model, I've got the properties. I've just determined the names of the boundaries, but I still need to give the boundary conditions with commands. So I need a data file here. So I'm going to go File, New Data File. I'm going to start by restoring the save state that I just created. So model restore quotes slope 1. Oh, I need to give the boundary conditions. So zone, face, y, val, x, 0, range, group, west, or east. That makes sense. So I'm assigning a 0 velocity boundary condition on the left side, it's called west, and on the right side, which is called east. And I'm going to assign zone, face, y. This time I want x and y velocity to be 0, so I just say vel 0, 0. I just give a vector, range, group, bottom. We're almost done here. This is, again, the simplest example you could probably ever create. Model, gravity, gravity, 10. So I don't know if you've talked about this already. You can give a gravity as a vector, which is almost always going to be 0 in the x direction and negative in the y direction. You could say model gravity 0 minus 10 or minus 9.81. If you just say model gravity 10 and give a number, it assumes you mean it's acting in the negative y direction, because that's 99% of the time what you want to do. Model large strain off. And so now I want to run the factor of safety analysis. It's super easy. All you have to do is say model factor of safety. And that's the bare minimum. And it will go off and chunk away and do this binary search. And it will create 3 save states. It will save the initial state. It will save the state just before it's unstable and the state just after it's unstable. And it will just give them names at random, not random, they call them like FOS stable and FOS unstable. If you want to give them file names that are useful, you can add an extra keyword here, file name, FOS1. And then the last thing we have to do here, again, you would never do this in real life, but for this example, you give the word associated. So what it's going to do is, remember I said it reduces the cohesion and the friction each time. It's actually going to reduce the dilation as well so that it matches the friction. So we can get this analytical solution. 99.9% of the time you would not do that, but we can do it for this example. I'm pretty sure the only reason this keyword is in here is just for this example. And that's it. And then we're done. It's just going to chunk away and do its binary search. So you should, assuming you've got no typos in here, you should be able to run this thing. You should be able to watch it. It's actually pretty fast, but you can see it's telling you the stable, the unstable, and the current. I went too fast for me to explain what it was doing, but and at the end, it pops up with, tells you on the screen, factor of safety is 1.05. Oh, come on, I want bigger font. And now you can see I've got these 3 save states over here, the initial, the stable, and the unstable. The interesting one, of course, is the unstable state. I can double click on that. And now we want to make a plot. Let's hide the console. I'm going to make a new plot. Just click this little down arrow here and add the zones. Changes the contour. Displacement, slightly odd looking displacement because what we actually did in this example was turn on the gravity and then just started running the factor of safety analysis. Probably what you would do in reality is turn on the gravity, do a solve, reset the displacement back to 0, and then do the factor of safety analysis. So what's happening here is we're getting a bunch of downward displacement just due to the gravity that we don't actually care about. If you plot, so what people often do when they're trying to look for failure surfaces in this thing is under here, under zone value, you can change it to strain rate. And change it to maximum shear under the quantity. And I don't know if you talked about this yet, but when you plot stresses and strains, FLAC2D and FLAC2D by default, each zone gets its own color, but you can smooth that out under here where it says method, change it to volumetric averaging. So you get some nice looking contours where the failure surface is. And also, if you want to put vectors on top of this thing. So anyway, I want contour, strain rate, maximum shear, volumetric averaging. Finally, I could put vectors on here. This means changing the velocities. And then one other thing you can do on here is if you go to the plus, the plot item list, under miscellaneous, there's something called factor of safety. If you double click on that, it actually puts the factor of safety in the legend. So if you're printing this off, you can say, oh yeah, here's the unstable state with the factor of safety of 1.05. So you can see we're off from the true solution by about 5% here. Again, this is a relatively coarse mesh. So we could theoretically go through this again and fine. Just for fun, just to show you the fun thing about using commands here. We could go through this exercise again and build this thing with finer mesh. But if you go to slope1.save, so double click back to the slope1.save. So this is, remember we did the sketch, built the zones, and then we assigned the properties, we assigned the face group names. We did all that graphically, right? But it was actually spitting out commands the whole time. So you can get those commands. You can go to, I need to bring my commands back here. I'm looking at this command console here, and I go to state record. This is actually a record of all the commands that it spit out while we were doing that stuff with the mouse. So I can right click on that. They save to file as data file. Call it sketch. Now I can open it. I can go file, open, and open that thing that I just output there, sketch. That. And depending on all your mouse clicks here, on my example, on line 9, it says sketch set automatic zone direction construction edge 1. I can just change that to 0.5. I'm going to get a fine in that. One thing I need to do though is put a model new at the top, because otherwise it's going to try and build zones on top of the zones that already exist, right? So I can make 2 changes to this. I can put model new on the top and set the zone size to 0.5. I can run this whole thing. In theory, I should get exactly the same model with smaller zones. And then in theory, I can go back to my slope.dat and just run that again. might be able, I could change the file name here to maybe FLS2. I can compare and contrast the cases. It's going to take a little longer because they, I go back to the console and see it going. There's more zones here, so it's going to take a little longer, but now you can see it trying to narrow in on it. And as Andre noted, it actually starts at 1. It struggles a little bit, but I got a bit more accurate answer. I got 1.03 now instead of 1.05. So I can go back to my plot and I get a little bit of a nicer. Oh, I need to choose FOS2 unstable state. Because I've got a higher resolution, I get a nicer looking failure plane here.